After studying in detail about the principle of superposition, here's the time to go into some basic numericals. This is the first numerical. This numerical states that there are three charges and these charges are separated along the three corners of an equilateral triangle. Each side of an equilateral triangle is given to you, that is 0.1 meter. Now, let me draw the diagram. So now this is the diagram. You can see that three charges are given to you, that is at point A, this is your point A, the charge is plus 10 microcoulomb. At point B, the charge is plus 5 microcoulomb, and at point C, the charge is minus 5 microcoulomb. Apart from that, the side given to you is 0.1 meter each. Now let us see what is the property of an equilateral triangle. The equilateral triangle has a property that all the three sides are equal to each other, and apart from that, the angle, all the angles each is of 60 degree. Now your question is that you have to find the resultant force at point A. Now let's start the question. In this case, first you have to do that you have to find all the charges which are nearest to point A. So now look at this diagram. This is point A where you have to find the resultant force, and the nearest to this point A is point B and point C. So now you have to undergo through the two rules, that is, it has the polarity of positive, B has the polarity positive. Positive and positive, they repel each other. So in this condition at point A, the force exerted by the charge at point B is the force of repulsion. And what is the direction of repulsion? It is away from the charges. So this is the direction of force of repulsion. Now, what is the notation for it? It is represented as capital F A of B, as it is a vector quantity which shows some magnitude with a proper direction. Now, one thing you have to note is A, B. These are the variables. Okay, this cannot be altered out. That is, you cannot write it as BA. Why? Because it signifies that the force is exerted at point A by the point B. So that means it is written in the same manner. Same is the condition with C. You have to find the same force at point A by the charge C. Again, check the polarity between the two. Point A has a polarity positive, point C has a polarity negative. Positive and negative, they attract each other. So in this condition between A and C, there exists a force of attraction. And what is the direction? It is obviously towards the charges. So this is how the force of attraction is shown. How it is notified? It is notified as F of AC with a vector sign on it. AC means the force at point A by point C. You have to find the net resultant force. But before going into that procedure, first let's go into the Coulomb's law. According to the Coulomb's law, we can find the individual forces, that is F of AB and F of AC. Now let's start with first F of AB. F of AB, which is a vector quantity, is written as 9 into 10 is to the power 9. This is a constant. Apart from that, Q1 and Q2. Now, what is the charge at Q1? The charge at Q1 is at point A. This is a point A and the charge is plus 10 microcoulomb. Now, 10. But look at the unit. It is microcoulomb. You have to first convert it into coulomb. How we can convert it? We have to multiply it by 10 is to the power minus 6. So now it turns into coulomb. So here the value written as 10 into 10 raised to the power minus 6. Next is the Q2. Q2 is the charge at point B. So the charge at point B is plus 5 microcoulomb. So it becomes 5 into 10 raised to the power minus 6. Apart from that, the distance between A and B. What is the distance between A and B? It is 0.1 meter. Unit is appropriate, so you don't need to convert it. As it is a vector quantity, so what will happen? There must be a unit vector. Okay. Now, if I take a magnitude, that is, I have to find only F of AB, not a vector quantity. So you have to solve only magnitude here. And on solving it, you will get the answer 45 Newton. Next, you have to find F of AC. So, F of AC now becomes 9 into 10 raised to the power 9. The charge at point A, again, 10 into 10 raised to the power minus 6 multiplied by the charge at point C. The charge at point C is minus 5 microcoulomb, but the negative sign is not considered because here I am talking about only magnitude. I am not concerned about the direction because this is not a vector quantity. So only magnitude is considered, that is 5 into 10 raised to the power minus 6 upon r square. The distance between A and C is the same as it is an equilateral triangle. Now solve it out, you will get the answer 45 Newton. Now we worked upon the two answers, this and this, but still your answer is unknown because you have to find the net force at point A. That is, if you go into this diagram, then this is F of AB, this is F of AC. What is the net resultant force? The net resultant force is found by the parallelogram law. For that you can refer my video, that is concept of vectors. Now, if I complete this parallelogram, then the diagonal of this parallelogram represents the net force, and this diagonal of a parallelogram let us represent by capital F. What is the formula for it? It will remain the same as in the case of a parallelogram law. That is, capital F is equals to under root F of AB square plus F of AC square plus 2 times of FAB FAC cos of theta. What is theta? Theta is the angle between FAB and FAC. So here you can calculate, it is 60 degree. This is a straight line, so 180 degree minus 60. This angle becomes 120 degree. So the angle between FAB and FAC will be 120 degree. So instead of cos theta, put the value cos 120 degree. Now, I ask you, what is the value for cos 120? It is minus 1 by 2. All the values are known to you. This is 45, this is 45, and cos 120 is minus 1 by 2. Put the value, and on solving you will get your answer directly, that is 45 Newton. So this is the net force at point A, and this is what you have to find. Now I hope so that the first numerical will be clear to you. That's the basic one. Okay. Now let's move on to some difficult portion of it. In that condition, this is your second numerical. Again, this is a equilateral triangle and 3 corners of the equilateral triangle are mentioned to you. But if you notice that there is a line mentioned that between point B and C, there is a point that is D. D is the midpoint between B and C, and the charge is also given to you. So now let me first draw a diagram and then explain about the numerical. Now this is the diagram. You can see that this is an equilateral triangle with 3 corners, that is A, B and C, and the charges also are given to you. Apart from that, there is a new point, that is D, which is at midpoint between B and C, and the charge given at point D is plus 75 Coulomb. You have to find the net force at point A. In this condition, again we have to go through every steps that we have done till far. That is, at point A we have to see that what are the nearest charges that surrounds the point A. So now, taking the reference of point A, point B, point D and point C, these are the 3 charges that surround point A. That means they produce some influence on the charge, that is plus 1 Coulomb. So we have to check that particular influence, which we named as force. I will start first with point B. In this condition, we have to check the polarity first. Point A has the polarity positive. Point B has a polarity positive. So positive and positive, they repel each other. So the force between A and B is the force of repulsion. So this is how the arrow represent, that is away from the A and B. And what is the notation for it? It is notified as F of AB. That is the force exerted at point A by the point B. Come to point C. At point C, the polarity is minus, and at point A, the polarity is plus. So there exists a force of attraction. So how we represent it? We have to represent it like this, because this is a force of attraction drawing the 2 charges towards each other. And what is the notation for it? It is F of AC, like this. Now, in this condition, the question modifies to that there is another charge that is at point D, and this charge is also influencing point A. Now, check the polarity between the two. It is positive and positive, so there exists a force of repulsion. So what is the direction of this force of repulsion? It is away from A and D. So it is represented as F of A D. Now we have to find the net force at point A. Now, in this condition, before proceeding further, you have to first go into the Coulomb's law in order to find all the individual forces. First, let us start with F of AB. So, F of AB is written as the constant 9 into 10 raised to the power 9 Q1, the charge at point A. The charge at point A is plus 1. So, it is in Coulomb, so you don't need to put any conversion. Now, the charge at point B is 100 Coulomb. So, now put the value here and divide it by R, that is distance between A and B, it is 10. So, 10 square. Now, cancel out the values, you will get the answer, that is 9 into 10 raised to the power 9 Newton. Again, using the same concept, you have to solve for F of AC. It also becomes 9 into 10 raised to the power 9. The charge at point A, that is 1. The charge at point C is 100. Don't consider the negative sign because we are taking the magnitude. Again, the distance between A and C remains the same as it is an equilateral triangle. Cancel out the values. You will again get the same answer, 9 into 10 raised to the power 9 Newton. Now, let us go and find out the value for F of AD. So, F of AD now becomes 9 into 10 raised to the power 9, which is a constant. The charge at point A, which is 1. The charge at point D, okay, it is 75. Distance between A and D. Take a pause because we still hadn't found the distance between A and D. So, how it is found? We have to go into the Pythagoras theorem because ABD, it is a right angled triangle. So, in this condition, hypotenuse square is equals to base square plus perpendicular square. Using the same concept, you have to find the value for AD, which is 70. AD square is equals to 75 meter. So, this is the value and this value you have to put here directly 75. Cut the value out, you will get the answer again 9 into 10 raised to the power 9 Newton. So, this is all we have worked out. We have used the Coulomb's law in order to find all the values for the corresponding forces. But you have to find the net force at point A and how it is done. Again, you can refer to my video, that is concept of vectors. In that, go to the topic that how the vectors are resolved. Okay, now F of AD is along a vertical axis, so it can be easily added up. Okay, now let's move on to F of AB. F of AB is inclined, it cannot add it up. So in that condition, you have to resolve it into two parts, that is along the y-axis, which is vertical, along the x-axis, which is horizontal. Okay, now how we will resolve it? If it is F of AB and I have to resolve it along the y-axis, okay, so this is how I am going to resolve it, and along x-axis I have to resolve it like this. Now, what is the angle that F of AB makes with that of the x-axis? You have to work upon it. This angle is 60 degree, okay. It is a straight line, so this whole angles become 120 degree. This line is half of that particular angle, so it becomes 60 degree. So, the angle between F of AB and the x-axis is 60 degree. Using the same concept that I already mentioned, you have to resolve into y and x-axis, and along the x-axis, the formula becomes F of AB cos 60 degree. It is a vector quantity. Along y-axis, it becomes F of AB sin 60 degree. Likewise, you have to solve for F of AC also. This is also inclined at a particular angle, but it is going downward. So, in this condition, this is the x-axis, okay, but the y-axis should be downward because the vector is also downward. And I have mentioned in the vector that the vector which is to be resolved should lie between the y and the x-axis. So, in this condition F of AC, you can see that it is in between y and the x-axis. That means you are going on a right path. So, on resolving it, you will get F of AC cos 60 degree, it is also a vector quantity, and along the y-axis you will get F of AC sin 60 degree. Okay, now this is all what we have solved, but look at the diagram, it's a totally mess. Okay, hardly you can understand it, what's all going on. So, in order to understand it in a better way, I am going to resolve this diagram or simplify it in a much simpler manner. And how it is done? This is the next step. Now, as I promised to you, so this is the diagram that I have simplified. So easy to look, okay? And this whole mess reduces into such a simpler diagram. So you might be wondering that what I have done in order to reduce this diagram. Only some basic steps. So we have to first write down the resultant at y-axis. The resultant at y-axis means what I am telling you, that is all the vectors which lie along the y-axis. So in this condition, this is first vector f of AD. So I am going to write this vector f of AD. Now the second vector along the y-axis is f of AB sine 60 degree. So write down f of AB sine 60 degree. Now this is also a straight line and the vector along it is f of AC sine 60 degree, but it is going on a different path, okay? It is going in negative axis. So the sign is minus of f of AC sine 60 degree. Now you can see f of AB, we have seen 9 into 10 raised to power 9, and f of AC also have the same magnitude. So we will cancel it out. Only RY is left with f of AD. That is also we have found, that is 9 into 10 raised to the power 9. Okay, this is the magnitude I am talking about. If we have to take the magnitude at the resultant y-axis. Similarly, you have to solve for Rx, that is the resultant at x-axis. Rx, okay, in this condition, what are the vectors that lie along the horizontal line? In this diagram, you can see this is the horizontal line and the vectors lie are f of AB cos 60 degree and f of AC cos 60 degree. Both are going along the same direction. So you have to add these two vectors. On adding, you will get f of AB cos 60 degree plus f of AC cos 60 degree. Now we already worked upon the value, that is f of AB and f of AC. Put the value here. Cos 60 degree is 1 by 2. On solving it, you will get the answer 9 into 10 raised to the power 9 Newton. So here also the case is Newton. This is the magnitude that we have found, that is R of X. Now we have worked upon all the quantities, that is the resultant at X direction, the resultant at Y direction. What is your purpose? Your purpose is to find the net force at point A. Again, go into the parallelogram law. If I complete this parallelogram, so the resultant is my diagonal, that is the diagonal of a parallelogram. This diagonal of a parallelogram is represented by R. If you have to find the value for R, then use the same formula that we have done so far. Now using the formula, that is R is equals to under root Rx square plus Ry square plus 2 times of Rx Ry cos of theta. Okay, this is the formula. If you remember, I already worked upon it. The theta is the angle between Ry and Rx. So the angle between Ry and Rx is 90 degree. What is cos 90 degree? Cos 90 degree is 0. So this whole value now comes to 0 and your formula modifies into Rx square plus Ry square. Now look at this formula. Do you remember some similarity between this formula? Yes, this formula somewhat resembles to that of the Pythagoras theorem. So we can say so that if the angle between the two vectors, that is along the vertical and along the horizontal, is 90 degree, so in that condition the parallelogram law can be resembled to the Pythagoras theorem. Okay, we are not going into the basic because that's not so important for you. You only have to put the value for Rx and Ry. We have already solved the value, that is 9 into 10 raised to power 9 whole square plus 9 into 10 raised to power 9 whole square. Solve it out, you will get 9 under root 2 into 10 raised to power 9 Newton. So this is the value for R, which is the resultant at point A. Now there is another part, that if this resultant makes an angle beta with that of the x-axis, then what is the value for beta? In parallelogram law, there is also a specified formula for that. That is tan beta is equals to Ry sin theta upon Rx plus Ry cos theta. Theta is 90 degree, sin 90 degree is 1. Cos 90 degree is 0. So your formula modifies into Ry upon Rx. put the values, both the values get cancelled out because both having the same magnitude. In this condition, you will get tan beta is equals to 1 and beta is equals to tan inverse 1, which is 45 degree. So first answer is this, that is the magnitude, and the second answer is this, that is the angle between the resultant with that of the x-axis.